Welcome back to Architecting Intelligence. Look, our first three explainers expose the hidden costs and structural traps of enterprise AI. Today we fix it, because honestly, if your production system is sending a simple yes or no intent verification prompt to a massive frontier model right now, you are just burning cash. It's time to solve the model routing problem. In this explainer, we're going to dismantle those lazy defaults that are draining your infrastructure budget and design a system built around actual task requirements. All right, let's look at this number, $18,000. That staggering figure right there is the bloated monthly cloud invoice hitting your desk for what is, frankly, a very modest 100,000 request per day enterprise AI deployment. Why is it so high? Well, because you're paying what we call the frontier tax. You're rounding every single task through your absolute most powerful, most expensive frontier model. Now, sure, the system works. Your users are happy, no error codes are flashing, but financially, your margins are just bleeding out. It's a failure, but it fails completely silently. The core issue boils down to this one simple truth. As principal AI architect Parth B Joshi points out, your most capable model is not your best model. Now, the instinct that gets you into this mess, it makes total sense during a pilot phase. When you're piloting, you optimize for capability, right? You want the demo to work flawlessly, so you just throw the biggest model at it to avoid debugging. But the problem is when that pilot instinct calcifies into your production architecture. Assuming you have to use your biggest model for everything is a massive architecture mistake. This is exactly what that margin collapse looks like in practice. Your current architecture, it's literally like using a massive, gas-guzzling commercial semi-truck to deliver a single, tiny envelope, say for PII reduction or basic intent classification. I mean, sure, it gets the job done, but at what cost? On the flip side, the real fix is deploying a fleet of agile delivery bikes. These are your open-source or fine-tuned specialist models. They're built to handle precise, lightweight tasks incredibly fast and way, way cheaper. Let's actually do a quick forensic audit of your production traffic right now. Mapping out what your system is actually doing all day completely shatters the illusion that everything needs a giant LLM. On average, only about 30% of your production traffic requires genuine reasoning. A massive 50%, that's just structured processing, stuff like transforming or extracting data. And the remaining 20% is purely deterministic logic. That means up to 70% of your tasks do not require frontier capabilities whatsoever. You are basically using a surgical scalpel to cut packing tape. All right, Section 1, the three-tier AI architecture, designing around task requirements. To dismantle that wasteful default habit, we really have to design around what the task actually requires. Here, we're mapping out the exact engineering shifts you need to optimize for cost, latency, and reliability. We're taking that traffic from our previous breakdown and giving it a specific logical home. We've got Tier 1 for the heavy lifting, Tier 2 for specialized processing, and Tier 3 acting as our deterministic gatekeeper. By applying this exact framework, you're essentially pre-sorting your computational workload way before you spend a single dime on inference. So let's break these down, starting at the top. Tier 1 is the heavy lifter. This tier is reserved exclusively for genuine reasoning tasks. Ask yourself, when does a model actually need to synthesize information across multiple conflicting documents? When does it need to navigate deep ambiguity or make a really complex judgment call? Well, that is when you escalate to the frontier giants. In Tier 1, the massive capabilities of a frontier model actually earn their keep, and the quality difference is absolutely noticeable to the end user. But the crucial point is how we handle everything else. Enter Tier 2, the specialist. This is where intent classification lives. Intent classification is basically a structured processing task where a really fast, low-cost model transforms, extracts, or formats information based on highly predictable rules. Trust me, a targeted 7 billion parameter model that's been fine-tuned specifically on your company's data schema will absolutely crush a general-purpose frontier giant on these tasks, and it'll do it at half the latency. Finally, we have Tier 3, deterministic logic. Think of this as the gatekeeper. Look at these tasks: database lookups, regex-based pattern matching, policy evaluations, simple math. Listen to me on this one. You should not be invoking a language model at all for these operations. Sending these through an LLM just adds unnecessary latency, non-determinism, and a whole governance surface that simply doesn't need to exist. But, identifying these tiers is really only half the battle. Now we have to actually route the traffic. Which brings us to Section 2, building fallback cascades, the routing layer logic. So, this routing layer relies on fallback cascades to seamlessly move traffic around without breaking the user experience. Here is exactly what happens under the hood. Step 1. The router reads the incoming request and classifies the task type, assigning a confidence score. Step 2, it checks the runtime cost budget for that session. Step 3, it routes the request straight to the designated tier. But what happens if a small Tier 2 model fails an evaluation check, or maybe that confidence score is just too low? Well, that brings us to Step 4. We seamlessly escalate to the Tier 1 frontier model. The user never even sees a hiccup. And this brings up a super critical architectural philosophy. When your routing classifier is uncertain, like when it's dealing with ambiguous edge cases, you must always default to routing up to the higher capability tier. Why? Because overcaution in a fallback cascade is incredibly cheap. Spending a fraction of a cent more to ensure a good answer, totally fine. But undercaution, routing a complex problem to a small model that then hallucinates, that degrades your product. Actually, scratch that. That is a full-blown quality incident. Now, because this routing layer is making so many autonomous decisions, it quickly becomes the unsung hero of your stack. But it must be heavily governed. You have to treat model routing as core infrastructure, not just some configuration file. Keep this logic in version control. Track the initial classification against the actual model that was ultimately used, so you can detect routing drift. And most importantly, literally do not ignore this, never let your router dynamically adapt or learn in production without a human review gate. If your routing shifts dynamically, your cost and quality profile will shift without warning, and you do not want that.
Section 3, the payoff. Token efficiency, sustaining the AI stack at scale.
Okay, so what's the ultimate reward for actually building a well-governed 3-tier fallback cascade? Maximum token efficiency. And hey, the math does not lie. Let's look back at our 100,000 requests per day system. If you stick with the default instinct and send absolutely everything to a frontier model, you're burning up to $18,000 a month in inference alone. But if you apply the task tier framework, routing 50% to Tier 2 and 20% to Tier 3, your monthly inference cost plummets to roughly $3,500. You are saving over $14,000 a month on the exact same request volume without sacrificing quality where it actually matters. To put that into perspective, that translates to a massive 65 to 75% drop in inference costs. But you know what? It's not just about the money. Beyond cost, there is a huge latency payoff here. Mid-tier models process tasks 2 to 4 times faster. By offloading 70% of your traffic away from those bloated frontier models, you drastically lower your P95 and P99 latency. You prevent timeouts during load spikes. Your application goes from feeling, sluggish and unreliable to feeling pretty much instantaneous. So I'm going to leave you with this final provocative thought as you go to audit your own systems. What percentage of your daily requests genuinely require frontier capability? Honestly, I guarantee it's lower than you think. Stop paying the frontier tax for basic text manipulation and simple deterministic lookups. Do this architectural homework assignment, map out your tiers, and start building a sustainable AI stack. Hit subscribe so you don't miss out, and join us next week as we wrap up this operational phase in our next explainer. Thanks for watching.